Okay, so here are a couple more examples on how to use solubility rules to write net ionic equations. So I've pulled up a document with the solubility rules here on top just for quick reference. So our first example here, let's say that we're going to mix strontium chloride and sodium carbonate, right? We want to know what the equation is going to be. First, we need the formulas. So in order to write the formulas, we need to know the charges. So look up on your charge sheet. Chloride is -1, strontium is +2. So that means SrCl2. And sodium carbonate, well, sodium is a +1, carbonate is a -2. So the formulas are written this way. So these two are going to combine. We're going to write the ions as products. So, I'm sorry, the ions as reactants. So here's my strontium. I have 2 chlorides. I have 2 sodium ions. Remember that we don't write ions diatomically, right? Whenever we are dealing with ions, they are to be separated. Okay, now, when they ask us to predict the products, these reactions will mostly be double replacement, which we've studied before. So the cation of the first formula goes with the anion of the second formula, and vice versa. So my combinations then will be sodium with chloride and strontium with carbonate. Now, I am keeping in mind their charges, so I'm checking to make sure I'm writing these product formulas correctly. Sodium is +1, chlorine is -1, strontium is +2, carbonate is a -2. All right, so now it says consult solubilities. So I have 2 products. I need to figure out if any of these are soluble or insoluble. So for the first one, I like to go with the anion first. I look up the chloride, and so the rule for chlorine is actually in the family of halogens, so it's called a halide. And the rule for halides is that all compounds are soluble except silver, lead, and mercury. Well, sodium is not silver, lead, or mercury, so I know that this one is going to be aqueous. Aqueous means soluble. Okay, so for strontium carbonate, let's look up and see if carbonate is found anywhere, and here it is. So all compounds containing carbonates are insoluble, right, except for alkali metals and ammonium. Well, this is not an exception. This is insoluble, so we write S for solids. So, write to the ionic equation. So the ionic equation is going to conclude all ions except, we're going to leave the solid intact. So, Sr2 plus, 2 chlorides, 2 sodium ions, a carbonate ion, and our products were sodium ions again, chloride ions again, and SrCO3, which we said was insoluble. It's our solid. All right, so algebraically, we will cancel the spectator ions, so that means anything that appears as a spectator ion on both the left and right side, so sodium, for example, chlorides, for example. And what we're left with is the strontium ion, the carbonate ion, and the product, strontium carbonate. And it helps if you circle the net ionic equation. Okay, let's do one more example. Magnesium chloride and sodium phosphate. All right, so magnesium chloride. Magnesium's +2, chloride's -1. Sodium phosphate. So phosphate's a -3, sodium's a +1. So the formula is going to look like this. So I'm going to do this a little bit quicker. I'm not going to break down all the steps. I'm going to just jump straight to predicting the products. And the double replacement rule tells us that we will get NaCl and that we will get magnesium with phosphate. So this is tricky. Magnesium is +2, phosphate's -3. So Mg3 parentheses PO4 2. Okay, so Let's balance this. So 2 phosphates, 6 sodiums, 6 sodiums. Okay, now we are balanced. All right, so now we check our solubilities. So the solubility rule for chlorides, we've already addressed that. We said that the halides are all soluble except for silver, lead, mercury. So that's going to be aqueous. And the phosphate rule says they're all insoluble except for alkali metals and ammonium. And this magnesium is not an alkali metal, so there's not aqueous. This is going to precipitate. It's going to be our solid. All right, so we've established what our solid is. Let's break up all of our compounds into ions. Notice that I have 6 chlorides because I had the coefficient of 3 and I had the subscript of 2 on chlorine, right? That makes for 6 chlorides. Likewise here, 6 sodium ions, 2 phosphates. All right, then 6 sodium ions, 6 chlorides, and then our solid product. Notice that I'm not writing AQ after every single ion. If you're writing a formula of an ion with a charge, then writing AQ is assumed. It's not necessary. So that's to save a lot of writing. I didn't write AQ after everything. But you always have to write the solid, liquid, or gas states for the products. Like here, this solid here. The fact that this is a solid, that can't be ignored. Okay, let's cancel. 6 sodiums, 6 sodiums, 6 chlorides, 6 chlorides. All right, what are we left with? 3 magnesium. Oops, that was 2 phosphates. This is our net ionic equation. And looks like we have one more here. So I'm going to write the formulas out, and then you can pause, and you can try to write it yourself, and then you can unpause and see if you got it right. Okay, so pause here, look up your solubility rules, determine which one of these is soluble or insoluble. Okay, so chromates are insoluble, so that silver chromate is going to be my solid. All nitrates are aqueous. So now that we know we're focusing on silver chromate, let's break everything up. Let's cancel. And let's rewrite. And that's how you write a net ionic equation.